Hey everyone, today we're going to be learning about how we can solve the CCC or Canadian Computing Competition 2022 J3 Harp Tuning Challenge. Alright, before I go ahead and explain everything, you can also read the solution or the commentary on the problems, which kind of guides you on how you guys can figure out how to solve it. A very important concept to note when you're solving this problem is tokenization, and it perfectly explains it with the Waterloo. So I'm just going to use that, and then we'll get into how tokenization is actually used in this context when we're reading the actual problem, right? But if we look here in J3 Harp Tuning, right, it says there is a lot to consider when attempting to solve this problem. The biggest challenge is to break the input into pieces. This is known as tokenizing or tokenization. In this case, tokenizing because there's noun after. The input and the pieces are typically called tokens. So, okay, what does this mean now? You might be a little bit confused though. I'm going to actually show you this through a Google Drawing. All right, and so you're gonna have to I'm gonna have to use text because my Apple Pencil died. But so let's say we have some sort of text, right, or some sort of input. Okay, so in our input, let's say our input is like 1y7u. Okay, something random. Now, through the process of tokenization or tokenizing this input, what you're gonna do is you're gonna break this input into pieces. So what does this mean exactly? Well, we're gonna take each one of these characters and break them and put them and store them separately. Store them separately. And we can do this perfectly with the data structure of list, right? So we just do like this. Like that, right? So now each of these values, this is pseudocode, by the way. It doesn't represent any programming language. It's just to show you. But if I look over here, this 1, this 7, sorry, this y, this 7, and this u, they're all stored together, yes, but they're all stored in separate entities, right, in separate indexes, right, and each one of these can be called tokens. So that's tokenization, taking an input or a piece of value and breaking it into different tokens, which are just characters of that input. Okay, that's the easiest way you can think of this, right? So this is tokenization. Okay, all right, back to the problem. The CCC harp is a stringed instrument with the strings labeled A, B to T. Like other instruments, it can be out of tune. A musically inclined computer science student has written a clever program to help tune the harps. The program analyzes the sounds produced by the harp and provides instructions to fix the strings that is out of tune. Each instruction includes a group of strings, whether they should be tightened or loosened, and by how many turns. Unfortunately, the output of the program is not very user-friendly. It outputs all the tuning instructions on a single line. For example, the single line AFB plus 8 HC minus 4. That, to a normal user, would take some time to comprehend, and as software developers, we don't want them to have to do that, right? We want to make it as easy as possible to understand the outputs. And you can see in this, it actually contains two tuning instructions, which is AFB plus 8 and HC minus 4. The first instruction indicates that harp strings A, F, B should be tightened 8 turns. So you can see kind of how tokenization is already kind of playing a role here, because by the get-go, if you just look at this question, you can see that it's already starting to tokenize this output by specifying different characters which we can interpret as tokens. For example, A, F, and B. They're all part of this value, but they're all in separate entities, right? They're all represented as separate entities, and you can prove that because they're all in their own kind of square, right? And so that way we can kind of see that tokenization kind of playing a role already. Now the same thing happens with this, right? So the strings HC are loosened by 4 turns, and the reason why it's loosened and tightened here is because of the plus and the minus. So our job is to take this single line of code and make it easier to read. And then there are certain marks that you can get based on how well you're able to do the program. So you get 5 marks if you can do something like this, right? You get another 5 marks if you can add 2 instructions to the mix, and then you get 3 marks if you can add like multiple like letters, and then another 2 marks if you can do all of this. So basically you get more marks for how versatile your program is, right? And that versatility is actually not as hard as you think to do, and I was able to figure it out when I was in a good mind, clear conscience, and yeah, I'm ready to share that with you. But anyways, so over here in the sample input, right, essentially it's doing the same thing, right? And each of these strings, by the way, are kind of in their own, like in the output they're in their own lines, right? So that tells us that each of these are separate print statements, right? So here, first things first, how can we differentiate between because I don't only want 5 marks. I don't only want 5 marks, which is when you can only do 1 instruction. I want to get all 15 marks, right? That's what I got with my submission, right? So how can I do that? So the way that you'd be able to do that is the following. All right, you're gonna first take you're first gonna figure out a pattern. Okay, in this case, the pattern I see, and you'll see that in input 2 too, is that after the numerical value, which is the end of an instruction, if the next value is a alphabetical value, right, that signifies the end of this instruction and the start of this instruction. We can see that here too, right? Like you have A, F, B plus 8, right? And this signals the end, because we know that SC will signal the next value because of the fact that this is a numerical value, and the next numerical value the next value, not next numerical value, the next value S is actually an alphabetical value. So by just seeing this one little thing, it makes our whole program much more easier. Now, as I said, we're going to tokenize everything. So the way that the tokenization process would look like is something like this. And this is just sort of my work and what I've done. But if I just ignore that, ignore all of this, just look over here. So that's how it would look. So this is the input I gave it, and you can see, oops, let me go back. And you can see that we literally took every entity and put it into its own little index, and they're all considered a token, right? Now what we can do is we can just keep going, right? Going like scrolling, right, until we reach that numerical value. That numerical value. So the first time that would happen is here, right? Because this is numerical value. So okay, now this is numerical value. So now it will check if the next number is a numerical value too, right? If it isn't, right, or if it's an alphabetical value, that means the next instruction has started, right? Because of how the pattern works and the pattern we recognize. But here, that's not the case. So move on to the next value, right? In this case, it'll look to the next value, and it sees that it is an alphabetical value. So it knows that after this number, this current instruction is finished. So then what we will do is we'll actually keep track of the current instruction to a variable, and we'll just keep adding these words, right? Until we reach the end. And how do we know we're at the end? Well, if our current value is a numerical value and the next value is an alphabetical value, then we'll first print the current instruction, and then that variable will be wiped, so it's ready for the next current instruction, because we're done with this. So you can see how that will generate multiple print statements because of the fact that we're going to be printing the current instruction variable many times. Alright, so now that I've told you more about my logic, we are going to look at how we can actually implement this tomorrow. For now, I'm going to go to sleep.